Good morning and welcome to today's class. Today's class is a continuation of our previous classes on senior secondary school mathematics for class 1. In today's class, we shall be discussing the topic indices. Before we get to indices, we shall look at standard forms which will introduce us into indices. Standard form is a topic which we have done in junior secondary mathematics. And the objective of today's class includes how to express numbers in standard forms. We shall see how we can convert numbers from ordinary forms to standard forms. And we shall also be looking at representing indices and give examples using standard notation. As a revision, we say that very large and very small numbers can be conveniently written in standard form, and numbers expressed in the form a times 10 raised to the power of n is said to be in standard form, where a is a number that falls in between 1 and 10. That is, 1 is less than or equal to a and a is less than 10. So a can take the number 1 to 9. That is, 10 is exclusive. And n can be said to be either a positive or negative whole number. So once a number, an ordinary number, can be expressed in this form, a times 10 raised to the power of n is said to be expressed in standard form. For example, we have 600. 600 can be expressed as 6 times 100. And this can further be expressed as 6 times 10 raised to the power of 2, because 100 can be said to be a multiple of 10 twice. So this is said to be in standard form. Now, if you look at the condition given that a number must be expressed in the form a times 10 raised to the power of n, where a is a number that falls between 1 and 10, that is, with 1 inclusive, you will discover that 6 meets that criteria, because 6 is a digit that falls between 1 and 10, and 2 is a positive whole number. So such a number is said to be written in standard form. 3600, number 2, can be expressed as 3.6 times 1000. And this can further be written as 3.6 times 10 raised to the power of 3, because 1000 is said to be a multiple of 10. 10 multiplying itself 3 times will give you 1000, and such a number can be conveniently written as 3.6 times 10 raised to the power of 3. Now, if you look at it with this criteria, you will discover that 3.6 is a digit that falls between what? 1 and 10, as well as n, 3, is said to be a positive whole number. C, 3, we have 123,500 to be written in standard form. And this can conveniently be written as 1.235 times 100,000. 100,000 is said to be a multiple of 10, which therefore 123,500 can be expressed in standard form as 1.235 times 10 raised to the power of 5. Looking at it, 1.235 is also said to be a digit that falls in between 1 and 10, while 5 is said to be a positive whole number. I'll further give you an example on standard form. This is a common error by students who tend not to express numbers in standard form. For example, I'll pick one of these as an example. Let's look at number 3. 123,500 cannot be written as 12.3 times 10,000. Reason being that, okay, let me complete it. This will give you 12.3 times 10 raised to the power of 4. This cannot be said to be in standard form because these do not meet this criteria. Why? A says A is defined as a digit that falls between 1 and 10, but this is 12.3, of which 12 is more than 10. So that defies the condition. But rather, if you should move the decimal point one step forward, it increases the power to 5, which gives you the correct expression. Let's also look at powers of 10 in index form, because one may ask, how is Mr. Otaji being able to express 100,000 as 10 raised to the power of 5? Now, 100,000 can be broken down to be 10 multiplying itself 5 times, because 10 times 10 is 100, 100 times 10 is 1,000, 1,000 times 10 is 10,000, and 10,000 times 10 will give you 100,000. So that can be written as 10 multiplying itself 5 times. This is not equal to 10 times 5, so please take note, but rather 10 times 10 times 10 times 10 times 10 will give you 100,000, which we can write as 10 raised to the power of 5, because there are 5 digits of 10 in here multiplying itself. Also, if I'm asked to express 10,000 in index form, this is going to give me 10 times 10 times 10 times 10, and that becomes 10 raised to the power of 4. Similarly, 1,000 can be expressed as 10 times 10 times 10, which is equal to 10 raised to the power of 3. If you follow it in that order, you will discover that the power of 10 is a function of the number of zeros you have. When it was 5 zeros, we have power of 5. When it was 4, we have 10 raised to the power of 4. 3, this is 10 raised to the power of 3. Your guess will be as good as mine for 100, of which 100 can be written as 10 times 10, which is equal to 10 squared. If you follow it in that order, you agree with me that 10 can be written as 10 raised to the power of 1. What about 1? 1 is said to be 10 raised to the power of 0. And we have 0.1. 0.1 can be written as 1 times 1 over 10, because 1 divided by 10 gives you 0.1, and this can be said to be 1 times 10 raised to the power of -1. So this is where you begin to get the negative powers of 10, of which this can simply be expressed as 10 raised to the power of 1 minus 1, because whatever you multiply by 1 returns that value as the answer. 0.01 will be equal to 1 times 1 over 100, and this can be written as 1 divided by 10 times 10, which is equal to 1 times 10 raised to the power of -2, or 10 raised to the power of -2. Another way you can solve this is by moving the decimal point until it falls after the first significant figure. By doing that, you can say that 0.01 can be said to be 1 times 10 raised to the power of, then you move this decimal point number of times 1, 2, 3. So I have been able to move that decimal point 3 times from this its initial position, but because I was moving towards the right, the power of 10 is going to be a negative. So therefore this becomes 1 times 10 raised to the power of the number of times it was moved, which was 3 times. So this becomes 3. Same thing goes to this. This becomes 1 times, if you are with me, let's do it together. This becomes 1, 2, 3, 4. And this is said to be 1 times 10 raised to the power of 4. If you have another 0.00001 and you're asked to express it in standard form, if you should move it once, you can write it as 0.0001 times 10 raised to the power of minus 1, because we have moved the decimal point just once. This cannot be said to be in standard form because remember the rule that it must be expressed as a times 10 raised to the power of n, where a is a number that falls between 1 and 10, but this is still smaller than 1, so it cannot be said to be in standard form, but rather keep moving it until you get a digit which is equal to or greater than 1 but less than 10. So we are going to move this the number of times that will make such to be possible, and this becomes 1, 2, 3, 4, 5. So therefore this can be expressed as 1 times 10 raised to the power of negative 5. So this is now said to be in standard form. Let's take more examples. That we should express the following in standard form. 560. 560 can be written as, okay, let's use the second method I gave you, or we are going to use both methods. So this becomes 5.6 times 10 raised to the power of, how many times then move the decimal point? That will be 2, because from at the initial stage the decimal point is said to be here, so you move it 2 times and it becomes 5.6 times 10 raised to the power of 2, or you can express it as 5.6 times 100, which can also be written as 5.6 times 10 raised to the power of 2. Looking at it, 5.6 is a digit that falls between 1 and 10, and 2 is a positive or negative whole number. Also, B, this becomes, you move the decimal point number of times. If you look at A, when I moved the decimal point towards my left, we said it becomes positive, but when you move it towards the right, the power of n becomes negative. So this will now be equal to 5.6. if you move this 1, 2, this becomes 5.6 times 10 raised to the power of minus 2, because I moved the decimal point 2 times to the right, sorry. C, this becomes 2 times 10 raised to the power of, we are going to move the decimal point 1, 2, 3, 4, 5, 6. So this becomes 2 times 10 raised to the power of minus 6. More examples. That we should express the following in ordinary form. Now we have seen how to express numbers from ordinary form to standard form. In this second example, we shall be looking how to convert or express numbers in ordinary form from standard forms. So this is given as 3.16 times 10 raised to the power of 2. So we are going to take the reverse process as we did in the first example. This can be written as 3.16 times 10 squared simply means 10 times 10. 10 multiplying itself twice, which is equal to 3.16 times 100. So this is equal to, you move the decimal point now 2 times to your right, because initially we were moving it to the left, and in the reverse method you move it to the right. So this becomes 1, 2, and this is going to give us 316. Or with the help of your calculator, when you multiply 3.16 by 100, it gives you 316. Also, to make it faster, maybe when you are working, solving problems under objective that does not involve you showing working, this is what you do. 4.7646 times 10 raised to the power of minus 4 can be written as 4.746 times 1 divided by, this is 10 in 4 places, that should be 10,000. So which can be written as, because we are dividing by 10,000, we are going to move the decimal point 4 times to the left. In this case, when it is positive, when the power is positive, you move to the right. When it is negative, you move to the left. So when you move it 4 times, this becomes, I'm going to have something like this. I'm going to have 1, 2, 3, and 4. So fill these hills with zeros, and wherever you stop gives you your decimal point. So this is going to be 0. We have 3 zeros, 1, 2, 3 before the digits 4, 7, 4, 6. So this is the number that, when written in standard form, gives you this. I hope you are following. Also with this, now a quicker way of solving this is this: 5.82 times 10 raised to the power of 7. This is going to be, since I'm moving it because it is positive, and I'm going to move the decimal point towards the right, of which I have 2 digits already, I'm going to subtract 2 from 7 and add that equivalent number of zeros, meaning 7 minus 2 is 5. So I'm going to add 5 zeros to this, and that gives me my number, that is 5, 8, 2 with 5 zeros. 1, 2, 3, 4, 5 is said to be the expression of this standard form in ordinary form. So this becomes 58,200,000. We are going to take more examples or more exercises on standard form. This is to help you understand how numbers are written in index form, such that when we get to indices, it becomes an easy ride. Now let's express the following in standard form. 300 is going to give us 3 times 10 raised to the power of 2, simply because I have 2 digits behind. Moving your decimal point this way, 1, 2, it gives me 3.0 times 10 raised to the power of 2. This is going to be, since I'm moving the decimal point to my right, this is going to be negative now. So this becomes 2.34 times 10 raised to the power of what? Minus 1, because I moved the decimal point just once. And this is going to be, this is 5,746, of which the decimal point will be here. Okay, how do I know? Because this is 5,746. So the decimal point falls behind the last digit, which is the unit digit. So expressing this in standard form, if you move it once, okay, some of you said, let me move it once. But if you move it once, this becomes 574.6, which is still big to fit in that condition. And the condition says A must be a number that falls between 1 and 10. but 574.6 is too large and does not fall, is greater than 10. So move it again, 1, this becomes 57.46, is still too large. Move it again, becomes 5.746, which meets the criteria. So this becomes 5.746 times 10 raised to the power of the number of times that decimal point was moved, and that is what? 3. So this becomes 5.746 times 10 raised to the power of positive 3, because the decimal point was moved towards the left. Question 4, 0.000131. Okay, now this is going to, we are going to move it how many times? 1, 2, 3, and 4. So this becomes 1.361 times 10 raised to the power of minus 4. 5, this is 256,000. So the decimal point originally is here. Moving it, we have 1, 2, 3, 4, 5. So this becomes 2.56 times 10 raised to the power of positive 5, because it is moved towards the right, towards the left, I beg your pardon. Question 6, this is going to be 1, 2, 3. So we have it to be 6.25 times 10 raised to the power of minus 3 for same reason. 12,750, you move the decimal point 1, 2, 3, 4, and this becomes 1.2750 times 10 raised to the power of 4, positive 4. Question 8 is 0.000056, and this becomes 1, 2, 3, 4, 5. So we have it to be 5.6 times 10 raised to the power of minus 5, and 85 million. This is going to be just, okay, another way of doing it is, instead of you drawing lines, you can just count the number of digits that falls after the first significant figure. This is the first significant figure, which is 8. So the decimal point will be here. So how many digits do you have after the first significant figure gives you the power of 10? This becomes 1, 2, 3, 4, 5, 6, 7. So I'm going to write this as 8.5 times 10 raised to the power of positive 7. There are various ways in which you can solve this, which I'm exposing to you right now. For this, is going to be, decimal point will fall in here. So how many digits do I have before that point? This becomes 1, 2, 3. That means I have moved it 3 times, and this becomes 4.37211 times 10 raised to the power of negative 3. So these are exercises on how to express numbers in standard form. Now let's also see how to express them from ordinary form, from standard form to ordinary form. So in this exercise, we shall be expressing them from standard forms to ordinary forms. So this becomes 3.84 times 10 raised to the power of 3. It therefore means that I'm going to move my decimal point 3 times to the left, which is the opposite while I was converting it from ordinary form to standard form. So this is going to be 3.84 times 1000. So this is equal to, you move the decimal point 3 times, and when you move it, this is already 2 digits, and add 1 to it, add 1 0 to it becomes 3. So this becomes 3,840. That is when you move the decimal point 1, 2, and 3. Add a 0 to it, and it gives you this. Okay, so I won't be drawing all this arc subsequently. Next is 5.004 times 10,000. Okay, that's 4 digits, meaning I'm going to move the decimal point 4 times. I already have 3 digits, so I'm going to add a 0 to it. This becomes 50040. That is 50,040. A negative power, it means I'm going to be moving the decimal point 3 times to the left. So we already having 1 digit. All I need is 2 digits after the decimal point before the significant figure. So this becomes 0.0054. I hope you understand this. This is equal to how many digits before the significant figure? Is 3, because we have 1 less. So this becomes 0.123103. Then you write all the digits that were there initially. Number 5, this is going to be 0. We are going to have, this is 4, so 4 minus 1 is 3, so 0.1, 2, 3, 6 and 5. And if you look at it, converting it back, you have 1, 2, 3, 4. That's 6.5 times 10 raised to the power of minus 4. While for this is 6 times 10 raised to the power of 4. Adding 4 zeros after this, because this is positive, moving to your right, this becomes 6, 1, 2, 3, 4. That is 60,000. Number 7 says 2.5 times 10 raised to the power of minus 4. So this is going to be 0.3 digit, 3 zeros before 2, 1, 2, 3, 2 and 5. Number 8. Can you try this? Number 8, 4 times 10 raised to the power of 10, meaning we are going to have 10 zeros after 4. This becomes 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that of 8.2 times 10 raised to the power of 9, this can be written as 8, 2, and how many zeros? 8, because we already have 1 digit. So if you move it, you are going to have 8 zeros being added. So this becomes 1, 2, 3, 4, 5, 6, 7 and 8. Also, this is 2.43 times 10 raised to the power of minus 6. It therefore means that we are going to have 5 zeros before 2, because we are moving towards the left. So this becomes 0.1, 2, 3, 4, 5, 2, 4, 3. So with this, we have been able to express numbers from ordinary forms to standard forms, and from standard forms back to ordinary forms. That brings us to the end of this episode. In the next class, we shall be looking at laws of indices, having understood what we meant by indices and how to express numbers in standard forms. In the next class, we shall be looking at laws of indices and its application. Don't forget to like our videos and share with your friends. You can use the comment section to tell us how you feel about this video, why you watch and share. Do have a nice day and see you in the next class. Thank you.